Hello my dear students, today we are in a situation where we cannot meet in a single classroom. That is why our college authority decided some video classes, and you can see the video classes through our YouTube channels. Okay, so today we discuss the first chapter of the first book, which is electric surge and field. Electric surge and fields. The first question is, what is electric surge? What is electric surge? Electric surge is the intrinsic properties of elementary particle for which it gives rise to electric force between the objects. Okay, like mass, we know every body have some masses. Okay, every particle have their masses. Because of their masses, they will show the gravitational force of attraction, and we have already discussed the gravitation chapter in the last year. Okay, because of their mass, they will show the gravitational force. But all the elementary particles don't have the charges. A few particles like electron and proton have charges, and because of their charges, they will show the electric force. They will show the electric force, and electric force is much stronger than the gravitational force. Okay, so the you remember the electric surge is a scalar quantity. Electric surge is scalar quantity. Electric surge is scalar quantity. SI unit of electric surge, SI unit of electric surge is Coulomb, denoted by the letter C. Okay, and what is the dimension of electric surge? What is the dimension of electric surge? We can express electric surge in terms of current and time. Okay, we can express electric surge in terms of current and time. Okay, here current and time both are the fundamental units. Okay, then dimension of electric surge will be equal to your dimension of current and dimension of time, and dimension of current is your ampere and dimension of time is your T. So dimension of electric surge is equal to your A into T. Okay, and we know there are two types of surges. There are two types of surges. There are two types of surges. One is positive and other is negative. Okay, and we also know that the protons are positively charged and electrons are negatively charged particles. And the charge of a proton is how much? It will be equal to plus 1.6 into 10 to the power minus 19 coulomb. This is the charge of a proton. And charge of an electron is how much? Minus 1.6 into 10 to the power minus 19 coulomb. Okay. The charge of proton is how much? Plus 1.6 into 10 to the power minus 19 coulomb, and the charge of electron is minus 1.6 into 10 to the power minus 19 coulomb. Okay, the magnitude is same, but the sign is opposite. Proton is positively charged and electron is negatively charged. Okay, where we have find these protons and electrons. For this, let us consider an atom. Okay, this is an atom. Okay, and the center of the nucleus, center of the atom is positively charged. Center of the atom is positively charged, and that is known as the nucleus. Okay, that is known as the nucleus. And inside the nucleus, protons and neutrons are there. Protons and neutrons are there. Okay, the protons are generally positively charged, that is why nucleus is positive, and neutrons are chargeless particle. Okay, and electrons are revolving around that nucleus. These are the electrons which are revolving around the nucleus. Okay, so in an atom, the number of electron is equal number of proton. You remember, the number of number of electron is equal to number of proton in an atom. Or you can say total negative charge is equal total positive charge. And as a whole, the atom is neutral. As a whole, the atom is neutral. Okay, and we know that every body or every objects are made up of some atoms. Every objects are made up some atoms. So let us consider a glass rod. Okay, this is a glass rod. Okay, basically glass rod is an insulator. Okay, where electron cannot flow easily. Okay, and this glass rod is also made of some atoms. There are lots of atoms. Okay, whenever we rub this glass rod with silk cloth. Suppose this is our silk cloth. When we rub this glass rod with silk cloth, what happens? Positive charge will appear on that glass rod and negative charge will appear on the silk cloth. Okay, how this positive and negative charge will appear on the two objects? Let me explain. Okay, we have already told you every objects are made of some atoms. Okay, suppose this is the atoms, this is the surface atoms. Okay, this is the surface atoms of the glass rod. When you rub this glass rod, what happens? The valence electron, suppose this is the atoms. Okay, this is the atoms. When you rub this glass rod with silk cloth, what happens? The electrons may ejected from the atoms. The electrons may ejected from the atoms, for which the number of proton will be greater than the number of electron in the atom. So when one electron is ejected or one electron is lost from the atom, okay, what happens? The number of proton is greater than the number of electron. Suppose initially there are 10 proton and 10 electron is there, and when you rub this glass rod with silk cloth, what happens? One electron is ejected. Okay, then number of electron will be how much? There will be 9 electron and there are 10 proton. That means one proton will be alone here. In this atom, one proton will be alone, and that is why, and the charge of the atom, net charge of this atom will be equal to your positive, and the value of that charge, the magnitude of the charge will be how much? Q will be equal to your charge of the proton, which is equal to how much? 1.6 into 10 to the power minus 19 coulomb. If you again rub this glass rod, there may be a chances of ejecting another electron. Okay, here you are again rubbing this glass rod, the 2 electrons are ejected from the glass rod, and that 2 electrons are sticks to the silk cloth. Okay, that is how this glass rod becomes positively charged and silk cloth becomes negatively charged. So positively charged means what? This is the deficit of electron. Positively charged means the deficit of electron, and negatively charged means excess of electrons. That means positively charged means क्या हुआ है? उसमें electrons lost हुआ है, and negatively charged body means the excess of electron. Okay. If there are 2 positive charges, that means there are 2 electron lost in that objects. If there are 2 negatively charged, that means there are 2 extra electron on that objects. Okay, so you remember positively charged means the deficit of electrons. or you can say the excess of protons, and negatively charged means the excess of electrons, excess of electrons. Similarly, if we take a plastic rod, so this is a plastic rod, this is a plastic rod. If we wrap this plastic rod with wool cloth, wool, what happens? The plastic rod will become negatively charged and wool become positively charged. So here the wool will lose the electrons. The wool will lose the electrons because the electrons of the atom of wool are loosely binded. That is why the electron is easily ejected from wool. But in this case, the electron of the atom of glass rod are loosely binded. That is why here electrons are easily removed from glass rod. But in this picture, the electrons of plastic rod are tightly bound. That is why they are not easily ejected. Here the wool will lose the electron. That is why those electrons are stick to the plastic rod when you wrap this plastic rod with wool, and that is why this plastic rod will negatively charge and wool will become positively charged. Okay, so one thing you remember, negatively charged means the excess of electrons. Okay, if there are two negatively charged, that means there are two extra electrons. If there are three negatively charged, that means there are three extra electrons. Positively charged means deficit of electrons, or you can say the excess of proton. Okay. Next topic is electrostatic induction. Electrostatic induction. Okay, suppose this is a conductor, AB is a conductor. Conductor means the piece of rod where the electron can easily move. Okay, and this conductor is standing on an insulator. This conductor is standing on an insulator. Okay, whenever an electrified glass rod, so this is an electrified glass rod. Electrified glass rod means when you wrap a glass rod, it becomes positively charged, and that positively charged glass rod is known as the electrified glass rod. So this is an electrified glass rod. It will become electrified when you wrap this glass rod with a silk cloth. Okay, when you wrap this glass rod, it will be electrified. The positive charge will appear on this glass rod. This is our electrified glass rod. In electrified glass rod, the positive charge will appear, and we know that there is always attraction between opposite charges, and inside the conductor electron can easily move. That is why this positive charge will attract the negative charges, or you can say this positive charge will attract the electrons. Okay, and those electrons will leave some atoms, and in that atom the positive charge will develop, and those positive charge will appear at the further end. Okay, at the further end. So here you can see, when you bring an electrified glass rod near a conductor, what happens? Opposite charges develop at its closer end and similar charges develop at its further end. This phenomenon is known as electrostatic induction. Actually, this is a temporary electrification. Why it is temporary? When you remove this glass rod, what happens? They will again recombine. Okay, they will again recombine. That is why it is temporary electrification. And whenever you bring this glass rod near to the conductor, what happens? There will be again polarization. Negative charge, that means opposite charge will develop at its closer end, and similar charge will develop at its further end. Okay, this is the electrostatic induction. This phenomenon is known as electrostatic induction. Okay, this is our conductor. AB is a conductor and this is our insulating stand. Insulating stand. Okay. So electrostatic induction is a temporary electrification of a conductor in which opposite charges develop at its closer end and similar charges develop at its further end. Okay. Let me explain another examples. Suppose we have considered two conducting ball A and B. These are the two conducting ball, or you can say pit ball. Pit ball also, they are very small in size and their weight is very small. That is, they are known as the pit ball. Okay, the two pit ball are standing on an insulator. The two pit ball are standing on an insulator like this. These are the insulator. Okay, these are the two A and B. These are the two conducting ball. In a conducting ball, the total proton is equal to total electron. That means electrically both the ball is neutral. Whenever you bring an electrified glass rod, this is an electrified glass rod, what happens? Opposite charges develop at its closer end and similar charges develop at its further end. This phenomenon is known as electrostatic induction. This is our picture one. Okay, whenever you bring an electrified glass rod, what happens? Opposite charges appear at its closer end and similar charges appear at its further end. This is our electrostatic induction. In the second picture, keep the glass rod near to the conductor A. This is our conducting ball A. Just you make a slight separation between the two body. Make slight separation between the two body. Okay. What happens? The opposite charge will remain here and the similar charge will remain here. Okay. The picture is same, but difference is in the second diagram we just made a slight separation between the two balls. We just made a slight separation between the two balls. And in the third diagram, you just remove the glass rod. Just you remove the electrified glass rod. When you remove this electrified glass rod, what happens? You see, when you remove this electrified glass rod, the positive and negative charge will try to recombine. They will try to recombine because here I am removing the electrified glass rod. As removing the electrified glass rod, they will try to recombine, but they cannot recombine because there is a air medium which is a non-conducting medium. Through this non-conducting medium it cannot travel. That is why inside the two ball negative and positive charge will be trapped. Okay, and in the fourth diagram, okay, just separate the two ball. When you separate the two ball, what happens? The negative charge will be symmetrically distributed in the ball A and positive charge will be symmetrically distributed in ball B. Okay, you can make this experiment with plastic rod also. If you take this a plastic rod, if you take an electrified plastic rod, what happens? In electrified plastic rod, the negative charge will develop, for which this charge will be positive and this charge will be negative. Okay, if this is a plastic rod, this charge will be negative, this will be your positive and this will be your negative charges, and this will be your positive and this will be your negative charges, and it will be your positive and this will be your negative charges. Okay, so whenever you bring a plastic rod, this is the picture. Okay. If you take a single conducting ball, suppose we take a single conducting ball A standing on an insulator. Okay, and you bring this electrified glass rod, electrified glass rod, electrified glass rod. What happens? Opposite surges are developed at its closer end and similar surges are developed at its further end. Okay, this is our electrostatic induction, temporary electrification. Okay, suppose if you connecting this conducting ball with earth, earth means the source of surges, the source of surges. Okay, these are the positive surges and these positive surges are repelled by this positive surge. So what happens? Positive charge means the deficit of electron. Okay, positive charge means what? Deficit of electron. इसमें electron की कमी है. Okay, and the electron will go through this conducting wire from earth. The electron will go through this conducting wire from earth, and those electrons will fulfill the vacancy of the atom, for which the positive charge will be neutralized. And here we see the electrons are moving from earth to this conducting ball. That is why the current will flow from conducting ball to the earth. Okay, and then after neutralizing this repelling charge, you remove this connection, you just open the connection. Okay, and in the second picture, after opening this conducting wire, you remove this electrified glass rod. You just remove this electrified glass rod. When you remove the electrified glass rod, what happens? The negative charge will symmetrically distributed. Okay, so we can have a negatively charged ball with the help of this earthing wire. Question may come in exam, that is, what is gold leaf electroscope? Gold leaf electroscope. Basically, gold leaf electroscope is a device for detecting electric charge. That means, suppose we have a plastic rod and we rub this plastic rod with wool, then negative charge will appear on that plastic rod. How much negative charge will appear on that plastic rod? We don't know, because we cannot see the electrons. With this help of gold leaf electroscope, we can detecting the amount of electrons or amount of charge present inside this plastic rod. Okay, the apparatus is like this. Suppose this is a glass bottle with a rubber stopper, and this is your metal knob. This is your metal knob, and this is conducting rod, and these are the two gold leaves. The gold leaf, and this is a glass vessel, and this is a rubber stopper. And there is a tin foil inside the glass rod. Tin foil inside the bottle. Okay, whenever this apparatus is used for detecting the electric charge. How we will detecting the electric charge? For that purpose, you just made a contact with this metal rod of the plastic rod. Whenever you made a contact of plastic rod with the metal knob, what happens? These electrons are collected by the metal knob, and those electrons will flow through this conducting rod to the gold leaf, and those electrons are equally divided between the gold leaf. And you can see the two gold leaf are negatively charged, and they are very thin. That is why they will be repelling from one another, and by the degree of divergence, we can calculate the amount of charge present inside this plastic rod. So this is a very simple device. With this device we can detecting the amount of charge present inside a conductor.